Hi, on this video I want to talk about the 84 demo. Once again, you can find this in Files, Teacher Resources. Alright, and we're going to take a look at this circuit here. Now, what's interesting is I've been using this circuit. It comes right out of the teacher resource files, the multi-sim circuits. It's actually labeled 3.24A multiplexed SSD, but what you're seeing here is you're seeing a modified version of it. I have used the one that's in our LMS, our digital electronics LMS, for years, and I just have come to the conclusion here when I was working on some work for this class, our cohort, that there's a problem here with this circuit. And I happen to just be looking at it, and I was trying to set it up as a demo for you to use with your students to explain how a multiplexer works, and I couldn't figure out what the inverters were. They had inverters out here, and I know when we use this in the multiplex circuit to run two displays for now serving, that we use a BCD to 7-segment decoder that's set up for it's compatible to the common anode 7-segment displays, and on our board we have common cathodes, so we have to supply a positive value or a high to turn a segment on. Well, this had inverters on it here. Well, the BCD to 7-segment decoder has inverters on the output, so that makes that guy work okay. For some reason, it didn't make sense to have the inverters on this, and then I found some other issues, and it comes back to the actually the digital high is not compatible with these muxes, 2-to-1 muxes. And when you run two digital highs into a mux, what I was finding out was that the mux was inverting the signal. So you would have trouble if you downloaded this thing. And it was just interesting that 84 would work. So I've gone through and modified this, and actually I've modified this to help teachers demonstrate this. There's been a lot of corrections on it. I think these labels up here that actually control which 7-segment that you're using on the board, which one you're controlling or grounding, that's whenever this is a logic 0 up here, that display will be on. I've updated the names here. Over here, this was in the original document a 2 megahertz clock, but what's in the CMOD is an actual 8 megahertz clock, so I updated that information. But I did a few other things in here. We got this counter divided by 7 counter here. I'm sorry, 7-bit counter. There's another one here, another one here, and we were slowing the signal down to about 1 hertz. So this was the only output pin that there was, and it was actually connected up here to control the multiplexer. So if you had downloaded this, it would display 84 real slow, flashing back and forth. But what I did is I set it up here. I put a PIO input on here, and then I tapped off a few more signals off this 8 megahertz clock. And if you take a look at them here, I got the original one, which is less than 1 hertz. I have a 15 hertz tap, a 30 hertz tap, they're approximate, and approximately 60 hertz tap that you can switch here and actually show students. They can see that both displays are not on at the same time until you get up to 60 hertz. If you connect PIO 14 and 45 at 60 hertz, it looks like both displays are on both times. I have a little clock in here. I got the 5 hertz clock. In simulation mode, this is running. Matter of fact, that's what's running this out here to display, and I may adjust down a little bit lower when I talk about it. Over here, this is the fix to this that required inverters on these outputs over here. The fix is right here. I've taken I've inverted the signal, and out here through PIO 001, you actually have to physically tie this to ground. And I've run across this problem before. I don't know what the problem is. It's some of their conversion of the multi-sim circuit that they actually download. So download in the CMOD, and when they convert this, there's some issues with it, and I'm not sure why the problem occurs, but I found that if I do an external ground or an external high, in this case I inverted the high. All these red lines should be digital highs going in here, and I've got an external ground, and these are digital. Like here, for example, that's a digital high, that's a digital high originally on the circuit, digital high. Now I get that by tying PIO 001 to ground externally on the CMOD when you download this. But in order to make this work here, you have to have this at a 0, because if I hit the spacebar and change it to the 1, I think you'll see on the right hand screen there, all of a sudden our display stops. So this has to be a 0. We're running at about, I got this 5 hertz clock. I'm going to slow this clock down. I'm going to try, I'm just going to put 1 hertz in there for the time being. Let's say simulation is running. Oh, yep. I always forget. Got to shut that off. All right, so now the 1 hertz clock is in there. Start simulation up, and you notice this still is 84, but it's going to be running a lot slower. So whenever you see a logic 0 up here, for example, this will be dig 1, the most significant digit, and whenever that's grounded, that means this is going to be sent to the 7-segment display. So we'll watch. So it's grounded now. All the segments are turned on, so that's an 8. When this one is grounded, dig 0, that's going to be the 4. You can see there's 3 segments right here. 3 segments, A, D, and E are off. The other ones are on. So that's our 4. So you can use this to demonstrate to your students this multiplexer circuit. Like I said, it's kind of neat. I've put a lot of notes on here as to what you have to do and set it up for display with them. What I'm going to do is I actually have one running. And let me see. So here I have the 84 display running, and I have it, whoops, lost it there. See if I can get it back up. So I got the 84 display running, and it's actually connected to PIO 48 to 14 here, so it's less than 1 hertz. And what I'm going to do is I'm going to speed the display up, and we're going to go a little bit faster here with the display. So I move my little jumper wire, and now you can see the display. The display is running at about 15 hertz, swapping back and forth. Now you got to remember, I got a little camera on here, and the camera with the digital conversion, sending it serially over a USB cable to the laptop and then converting it back on my screen, you don't get the full effect. If you actually do this on a DMS board, you can actually see this. It looks pretty good flashing back and forth. All right, so I'm going to change this up to 30 hertz. Now, on this display here, you don't see any flashing, but on my physical board, I still do have some flashing. And finally, if I move this up to 60 hertz on the actual board, it looks like both displays are on. And I know it looks like both are on here in this simulation. But anyway, what I'm going to do is I'm going to attach this file. So if you want to use this file in the future, and I think I'm going to send this to Project Lead the Way, because the one that we have with our curriculum is incorrect and doesn't work properly. But at least this one you can do some demonstrations with your students if you haven't gotten here yet. Or you can go back, maybe you're past this and you're using 324B, which should help the students do the now serving and the 60-second timer. But anyway, this is just a good little demonstration of it. So I hope that helps you out. Thank you.